In this video, we will walk through a monohybrid cross. A monohybrid cross is a mating event between two parents that are heterozygous in respect to a single gene. This means that each parent carries two different alleles for the gene. In this case, mono, meaning one, refers to the single gene, and hybrid, meaning mix, refers to the fact that each parent has two different alleles. Let's take a look at a classic Mendelian example using pea plants. Pea plants have two possible pea colors, yellow and green, resulting from two different alleles. The yellow phenotype comes from the presence of the dominant allele, and the green phenotype is associated with the recessive allele. So the plant will produce yellow peas if it is homozygous dominant or heterozygous. And the peas will be green if the plant is homozygous recessive. So you have two parents that are heterozygous, and you want to predict what genotypes and phenotypes their offspring will have. When you set up a Punnett square for this cross, we can see that 1/4 of their offspring will be homozygous dominant, 2/4 or 1/2 of their offspring will be heterozygous, and 1/4 of their offspring will be homozygous recessive. This genotype ratio is a 1:2:1 ratio, which will be what you expect for every typical monohybrid cross. When you look solely at phenotype, you can see that 3/4 of the offspring will have yellow peas, and 1/4 of the offspring will have green peas. This phenotype ratio is 3:1, which will also be what you typically expect when you observe a monohybrid cross. So if you were to actually complete this cross, creating 100 offspring, you would expect to see around 75 yellow pea producing plants and 25 green pea producing plants, though you can't expect those exact numbers every time. Likewise, anytime you see two organisms of the same phenotype for a given gene produce an offspring phenotype ratio of 3:1, you can expect that both parents in that cross are heterozygotes. So that's all you need to know about the classic monohybrid cross. If you want to dig deeper, see my videos on dihybrid crosses and test crosses.